My name is Ross. I work at currently at the Berkeley Institute for Data Science, doing work supporting open source software, which includes NumPy. Most of my library specific work is NumPy and NetworkX, but I'm interested in the entire scientific Python ecosystem, and we have some really cool projects that are working on coordinating the effort between the various developer communities. And so that's how I spend my time. I've been working on NumPy since about 2019, but using it for like a decade before then. So yeah, it's been a very rewarding experience. And today, Anessa asked me to talk to you about NumPy tutorials. Let me go ahead and share my screen. So for those of you that don't know, um, we have this NumPy has this official tutorials site called numpy-tutorials that is accessible from numpy.org. It includes all these tutorials about we've broken it down to categories on features of NumPy, so looking closely at linear algebra, in particular singular value decomposition. And then there's another category of applications of NumPy for things that a lot of people find interesting, deep learning, image analysis, sort of iterative functional analysis, all kinds of cool things. And I'm going to just very briefly talk about how this NumPy tutorial site came to be and how it is maintained. So if you'll indulge me, I did put together like a little presentation that to sort of explain the thought process that went into developing this, or how we decided to organize the repo in this way. Um, and so just to start, we can ask a question. Do we really need more NumPy tutorials? I'm sure everyone here has Googled NumPy tutorial at some point. So I went ahead and just, this is a screenshot from last night. There's 20.5 million hits. So like that's quite a signal. Do we really need to be adding to that signal bucket? And at face value, you might think no, but I think there are some challenges associated with pedagogical material that are not always well addressed by a lot of the tutorial material that is available. And one of those things is pretty obvious. It's keeping things up to date, right? So NumPy is a living project. It is a library undergoing continuous development. And even though it has a very strong dedication to, stability and backwards compatibility, there are things, Python itself is a living language. There are new language features all the time. Same thing with NumPy. There are new library features. There are also patterns that maybe no longer make sense that are deprecated and or removed. And so any tutorial material, of course, should reflect those changes. Otherwise, you're learning outdated practices. And sort of a corollary to that is, the saying goes, there are many ways to skin a cat. There are many ways to solve a problem with any particular tool, especially one that is as flexible as NumPy. And, there are so many applications that can be addressed with array math, and many ways to solve any particular problem. So how do you know that when you're looking at a tutorial that the recommended way to solve a particular problem is actually a good way? Is it something that maybe a NumPy expert would do, or is it something that is maybe not recommended? And for this, I thought, oh, well, this sort of ruins it. Here, let me clear my outputs here. Otherwise, this is because these are supposed to be sort of fun little, uh, let's see. How do you do, oh, this one. Kernel restart and clear output. Okay, cool, because otherwise I ruined my surprise here. Okay, so this, I've sort of given away the answer for the first one, but let's say you have something like this. So you have an array, floating point numbers, very straightforward. You want to cast them into another data type. So, let's say you want 32-bit floats. You want to save some memory. You don't care that much about precision. So this is one way to do it. Does this look okay to everybody? Any objections to this particular usage pattern? There shouldn't be. It's pretty straightforward. And so you might think, okay, that makes sense. That's a way to cast to a different data type. So, I mean, let's say I want integers instead. And so I'll just do the obvious thing. But then, of course, you get this big, nasty red block because it turns out that int is a deprecated alias. And so I think that was 120. Yeah, it says in here 120. So that deprecation is probably going to expire soon. So this might turn into an error. And I'm certain that if you looked at least some of those 20.5 million NumPy tutorials will have this pattern in there somewhere. Just because they were written, maybe a long time ago and haven't been updated in a while. Another example of something like this is random number generation. This is one of the most popular subpackages in NumPy, generating random numbers. So if you want a 1,000 by 1,000 grid of uniform random numbers between 0 and 1, this is sort of the standard way to do it, or at least the pattern that almost everybody uses. But it turns out that there is a newer, better way that is recommended for new code. So if you're writing new code and don't have backward compatibility concerns, you might want to consider the generator API, which is slightly different, but has a lot of really nice properties, especially if you're using random number generators with in multiprocessing. But like one of the things is that the new generators are much more performant. Not that it's likely that random number generation is a bottleneck in your code, but regardless, that's still a good reason to maybe update, along with having some more flexibility in being able to select bit generators, so you're no longer tied to the Mersenne twister, which NumPy random, the random state object uses under the hood. I don't want to get in too much detail, but this is just another example of, the newest recommended best practice would be to use the new random number API. And this is something, again, that is probably not reflected in a vast majority of tutorials. This one, just yet another example, is just partitioning a domain. Let's say you want a domain in this case, you want to go from 0 to 5, endpoint not included, in steps of 0.2. So a very common thing that people do is use arange for this, and hey, that seemed to work, no problem. But what happened? The problem is that it doesn't always work. If you look here, you'll notice that there is an output that does not really look like it makes a whole lot of sense. So in this case, the endpoint was included, even though that's not the behavior that we wanted. And if you look more closely, this is just a result of numerical precision. If you were to look directly at the arange documentation, it is completely littered with, let me see if I can make that bigger. There we go. So there's an entire warning section dedicated to not using floating point steps with arange because of these numerical stability concerns. Specifically, this is sort of the crux of the problem. And so it has all kinds of strange and bad behavior related to floating point steps. But again, this is a pattern that you'll find very commonly in tutorials. And so that is just some sort of specific examples that highlight some of the challenges associated with pedagogical material. You never know that the best practices are always really represented. And so the question is, what can you do to address these issues? And I would argue that there's two main things that can really help. One is that to catch that first type of problem, is to make sure that the tutorials are well tested and continuously tested so that they reflect all the changes in the underlying library. This is just sort of like a standard best practice for open source software development, of course, like having continuous testing, usually as part of a continuous integration setup. The other thing is another of the core tenets of open source software development, which is code review. How do you determine that something is well written? Well, you have multiple people agree that it's the right way to solve a problem. And so that applies to pedagogical material as well. And this, in terms of code review, is especially valuable when you have the opinions of the people who are actively developing the library in question. That's not to say that there aren't power users or general people who really understand NumPy extremely well and write very good tutorial material. But for being up to date with the absolute latest in the library, the people who are watching the repo tend to have very valuable opinions when something like that is proposed. And so if you can hook into those experts who are very active in the community, then that gives you very valuable code review in the process. And so one of the requirements of this continuous testing is that the tutorial material should be easily executable. There are a ton of different ways to do this. This is sort of like a common best practice now. One of them would be to, for example, use a markup language plus have executable, Python scripts or whatever that generate the outputs. So if you have figures, if you have tables or whatever that go into the document, this is one way you could do it. This is the way that I wrote my PhD thesis. I had, LaTeX markup, and then all of the figures and everything were generated by Python scripts and embedded in the final document. I mean, the nice thing about this is that you can basically do whatever you want. There are, between LaTeX or restructured text, there are tons of markup languages that support basically every feature you could possibly want under the sun. The downside is that doing something like this is very custom. So with all of that flexibility comes a steeper learning curve, and you'll have a build system that is likely tailored to your specific use case, and it doesn't translate well to other projects, for example. So anything you learn is not necessarily generally applicable. So that doesn't scale very well. Another thing you could do is rely on things like Sphinx Gallery, which is an excellent plugin for Sphinx. And Sphinx underlies the documentation build system of basically every Python project, certainly every scientific Python project. So in that sense, it's really nice. It plugs right into the documentation workflow that people are used to working with. Though one downside of Sphinx Gallery specifically is that it wasn't really designed for narrative text. So if you've ever written like a gallery example, you have to use like #% to indicate that a markdown cell is coming or a restructured text cell is coming. And it's another thing that doesn't translate very well or isn't generally applicable. And of course, I left the most obvious case for last, which is Jupyter Notebooks. This is sort of what Jupyter Notebooks were designed for, to have interactive, an interactive platform for technical communication where you can execute the things inside the notebook. The other advantage here is that, notebooks have extremely wide adoption. It's very rare to come across someone who's never interacted with a Jupyter Notebook. But one of the big downsides of Jupyter Notebooks, of course, is that IPyNB file is really a JSON blob that is designed much more to be interpreted by browsers than by humans. So if you've ever tried to review changes in a notebook by looking at the diffs, you know that it's really annoying. So not only the structure of the file and all of the nested cells with braces and everything like that, but also there's metadata that changes and all these different things. So it's a really cluttered diff. It makes it very hard to review. So, I mean, there's the ideal solution to that would be if there were a text-based Jupyter Notebook format that wasn't stored as JSON. And that, of course, brings us to the punchline, which is there is now a text-based Jupyter notebook format. There's this project called the Executable Books Project. You can follow that link up there. I don't want to go into too much detail here, but I love the project. It has tons and tons of advantages. So, Jupyter notebooks are basically the main source of content. The current backend is Sphinx-based, so anyone who's used to writing documentation for any sort of Python project should be able to pick this up, or should be able to understand the underlying build system relatively quickly. The text-based notebooks, so they're written in a markdown flavor called Mist, which is basically extended markdown. It's Common Mark compliant, but also adds a lot of the RST roles and directives on top of it, which makes it much more featureful. It's a really nice format, and it supports code cells natively. So there's just a directive for making code cells, which we'll look at in detail in a second. And this, for people who are writing content, this is great because it means that all writing styles are supported. So if you like working with notebooks in the browser, either locally or on Jupyter Hub or whatever, and you like interacting with cells and are very comfortable navigating that way, you can write notebooks in that way, and that is totally supported by the website build system. Or alternatively, if you like working directly in a text editor, which is what I prefer, for example, then that workflow is also supported. And so that's really nice that authors can basically write exactly the way that they're used to, and it's a really nice advantage. And then finally, of course, there is the interactive component. So that means that all of the tutorials that we publish, there's basically just a button, and you can launch the tutorials on Binder or Jupyter Hub or whatever cloud-backed thing you want, including on a per cell basis with things like Phoebe, I forget what it's called, something like that. So you get interactivity essentially for free. And then there are a lot of other exciting developments about browser native things that you can do either through JavaScript or through WebAssembly that have received a lot of attention. And so I'm hopeful that there will be some really cool updates there in the near future as well. So follow that link if you're interested. Okay, that's a lot of talking, more talking than I intended to do. And so I figured at this point, what we could do is I could go through and do like find a change, like demonstrate how you would make a change to the NumPy tutorial site, just to sort of like demonstrate a possible workflow, or we can just talk about stuff. What do we think? Any preferences?
Demonstrating the workflow would be great.
Okay, so let's do that. I'll share my screen again. So, okay, I have a lot of terminals open. None of them are relevant. Let me go down here. Okay, so I already have this downloaded, so the NumPy tutorial site. I'm actually going to just work in this one because there is some cached data. But if you wanted to, if you wanted to do this from scratch, you just git clone. NumPy tutorials. So that's what it would look like. You do that, go to the, and then from there, in order to start working, it's very simple. All you have to do is install the dependencies. So if you use pip python-m, let's create a virtual environment. And this is, if you're a Conda user, of course, you can just do, Conda env create -f environment -YAML or .YAML. If you're a pip user, you can do this. What am I doing? Source bin activate. Okay, and then pip install. It's a little tricky because there's two requirements files -r requirements. We want this one. Hopefully I have most of these cached, so it shouldn't take a long time. And then there's another set of requirements for building the site itself. So these are the requirements that you would need if you wanted to just run the tutorials interactively. So if you wanted to go in here and open one of these Jupyter notebooks locally and run them, then you would need these requirements, but we also want to build the site. So pip install -r site requirements. And that would basically set everything up. So now you've got all of the things you need. I'm going to switch back to the one where I already have the data downloaded just because that can take a while. So basically this is where we left off in the other terminal, except I use a different environment management tool. Okay, so that's where we are. And so you would go into the site directory, and just like any Sphinx site, you just type make HTML, and that should go through, and you'll notice here that we have these executing notebooks. And so this is part of what the executable books project supports. They support cached execution of these files, which is really nice. The caching is at the file level, so it's not on a per cell basis, which means that if you have a tutorial where, let's say, one cell takes a really long time to run, then any time that you update that file, it will have to re-execute the entire thing. So the advantage there is that you don't have the classic Jupyter Notebook problem of mangled environments from non-sequential cell execution, which anyone who's worked in Jupyter Notebooks has probably experienced that problem. But the downside is that, it can take a very long time to re-execute the entire notebook. But that's what's happening here. And this is extra slow because the Zoom client takes up so much of my resources. Usually it should be much faster for you, assuming you have a decently modern computer. And in fact, okay, there it goes, it's done. And so that generates all the outputs in build HTML. So now if you want to look at the build output, oops, let's also close this. And I'll open a new one down here. Okay, so this is the same. It should look familiar. This is exactly what is hosted here. Oops, nope. So here's our local version. Here's the version that's hosted online. Same set of static files, super nice. And I last night spent a little bit of time trying to find something that we could do as like a demo PR, and I did find something in master arrays. So if you look at the master array tutorial, it basically uses some, this was written right at the beginning of the pandemic, or near the beginning of the pandemic. So it uses, pandemic case data as sort of the basis for looking at using NumPy master arrays to analyze data. And so that's what's going on here. And it's obvious why this is a good case for master arrays, because there's missing data. And so master arrays are one way to handle missing data. And in here, there is a fit of data that has a big chunk of it missing with a polynomial fitting model, specifically a cubic model. And this, it's currently using polyfit and polyval, and it turns out that those, if we look at, let's see, if we look at IPython and we look at polyfit, if you look here, so polyfit is, it's still part of the namespace. It's still available. It's not deprecated, but all of the poly functions have this warning in them that, you know, for new code, you should really prefer the NumPy polynomial package if you're working with polynomials. So this is a nice excuse to update some of the tutorial information. So what this would look like is, let me just open this browser on the side. Great. And what I will do is show how I would, like I said, I like working in a text editor, and I'd show how I would patch something like this. And so the first thing is, I guess I should have given a little bit of tour of the site, or a tour of the repo. So we saw that the requirements environment.yaml, this is all about setting up the environment, all the tools that you need in order to build things. This data directory is actually created automatically and contains data that is needed for the tutorials. And it's all downloaded during the tutorial execution, so you don't have to do anything special. And then there's two other directories. There's the website site, which contains like the source, you know, so these are basically the web pages. If you look at the index, you can see that, let me make this big again. This set is if we look there, so this is just like the markdown source file. If we go back to the tutorial site itself, you can see the rendered HTML, right? So this is basically the source file that gets converted into HTML by Sphinx. And it's written in this mist markdown format, which should be familiar to anyone who's used Markdown. There are some, or specifically RST. So you notice here, there's a talk tree directive. The syntax for mist is slightly different. So instead of using ... space, you know, talk tree, there's this triple backtick followed by braces. And there's a slightly different syntax, but it supports everything that restructured text supports. And that's sort of how that looks. So that is right now, all of the site files are contained here. And then there's a symlink back to content, which is where all of the notebooks are. So these are the notebooks that actually, the notebook tutorials themselves. We wanted to look at the master array tutorial. And so we can do that. In fact, I want to look at this from I'm going to use the symlink, and the reason why will become clear in a second. So if I do vim content tutorial ma.m, and so this is so here is the master array tutorial. And what we wanted to fix specifically, so the other thing that I'll point out is how the executable parts of the notebook are specified, and that's just in these code cell directives. So this is the equivalent of anything that's in a code cell like this is basically the executable cells in a notebook. Everything outside of it, like these are just normal markdown cells. And so this is, you know, this is basically how the structure of the notebook that you're used to seeing in the browser is translated directly into a text-based format. And what we wanted to fix was the polyfit. Oh, and I apologize that the code highlighting is not working in my current Vim environment, which I should fix, but oh well. And so what we had is we want to replace the polyfit with using polynomial directly. And so what we'll do is use the polynomial dot fit. So this is sort of the recommended interface for working with polynomials in NumPy is to use this class-based interface available in the polynomial subpackage. And so this is one of the things. There's a class method for fit for creating polynomials based on the model. And this is the same thing. So here's the X data here, and then the Y data, and the power of the polynomial. So what degree polynomial model do you want to use? In this case, so we have params, but let's just call this model because it's going to return a cubic fit. We don't need cubic fit anymore because we're going to use the model directly. So if we get rid of this and replace it with the model output, that should do it. Let me make sure that we didn't use cubic fit anywhere else. We did. Okay. So that's what that looks like. And now I'll just, everything is cached from the previous execution. So I should be able to just do that. Run make, build everything. Here's our website. Okay, so this is good. Apparently I screwed up because we got a cell execution error, but that's totally fine. We can just go ahead and find it. So if we find the masked array tutorial here, and we scroll down, eventually we'll see the cell that screwed up, and hopefully we can figure out why. Okay, there we go. There it is, the exception. Okay, so I deleted that params variable, which apparently was used in other cells. And there's this polyval too. So what we can do is go back here, go to find the polyval, there it is, and replace that with calls to the model directly. And there's a polyval down here. Let's see if there's any more polyvals. Oops, not polyval. Okay, it is up there in the text, which I'm not going to bother changing because what we're most interested in for the purposes of tutorials is getting the execution part to work. Okay, no complaints about errors this time. And okay, there's our output. So you'll notice that our changes to the code are reflected. Everything is executed automatically by the build process, so that's really nice. For comparison's sake, let's look at the hosted version. And so these are the figures in question. We're looking at this one. Of course, we get the same exact figure, which is nice. And then down here, we had the one with the 7 days after start. Okay, looks good. So yeah, I think we're pretty confident that we did that. And then the final remaining piece here is we've made these changes and now we want to actually get them into, submit a pull request to get them into the tutorials. So we can do that. And this is just, this demonstrates, well, we'll see why these text-based notebooks are so nice from a reviewing standpoint. And that's what this will really show. So let's go ahead and do this. We'll start by making a new branch. We're removing polyfit polyval, so we'll call it that. We want to make sure that the changes we make are things that we actually want to commit, and I think that is the case. We'll call this a maintenance PR. Okay, that's the commit message. That's done. I already have my remotes set up. So I have, the origin, which is my fork, upstream, which is the official fork. And then of course I review stuff. So these are just other origins from reviewing, remotes from reviewing. So I want to push to my fork, remove polyfit polyval. Great. And then we create a pull request. GitHub, numpy-tutorials. Let me make this a little bigger. So we see this, compare and pull request. I'm just going to stick with the commit message for now. We'll make this more detailed. And also remember that there are likely some changes that need to be made in the text too. So what I'm going to do is create a draft pull request. Which is totally fine. We'll put this in. Assuming that the button click works. Okay. And so the main reason for going through this process is so that you can see that, as I said before, one of the main things that we really need in order to be confident that tutorial material stays up to date is to have continuous integration testing. And so we have it configured so that the tutorials repo builds against the development branch of NumPy. So what that means is that any change that's proposed and merged into the development branch, we will see if that changes behavior in any of the tutorials before a release. And so that sort of has like double advantages. It sort of acts like an extra test suite for NumPy itself for user code, which is really nice. And so these, we also have a CI service that builds the documentation so that we can see what the rendered website will look like with the proposed change, which is a really nice feature. Unfortunately, these builds will take a couple minutes, so maybe we can revisit when this is done spinning. But that's basically the whole process. So that would be, changing an existing file. If you wanted to submit a new tutorial, which we very much encourage, there is a contributor's guide here, which has everything you need to know about submitting a tutorial to the repo. And so I'll stop sharing so we can actually talk, and we can answer, I don't know, any questions, any feedback, things you like, things you don't like.
Ross, thank you. That was very interesting. We have one question from Ayush, and
sure.
I believe Brigitte offered her answer, but maybe you would like to add. Ayush is asking, when is it a good idea to internally call the more performant function internally from the old one versus updating tutorial asking users to point towards newer endpoints?
I think it depends on a case-to-case basis. So for example, with random, right? If you look at the random package specifically, if you have existing code so the numpy.random, which is based on this internal object called random state, capital R, capital S, that's how like numpy.random.random is implemented. That has a global state variable set for the random module, and that is guaranteed to be self-consistent for old NumPy and all the way into the future for all future NumPy. So if you have stuff that you want to guarantee will be reproducible across all NumPy versions, then maybe that's something that you'd want to consider. Whereas the generator interface is a little different. There is no hard and fast guarantee that the underlying bit generators or generators won't be updated, which means that any code that you have will be reproducible within versions where those generator interfaces are the same, which would be something that you would just have to be aware of. So it's a trade-off. You get, on the one hand, you get forward and backward compatibility 100% guaranteed for free at the expense of worse statistical properties and worse performance versus and vice versa. So that's really the main consideration, I think, and that's for that specific case. For others, it really just depends. Like for polynomial, we recommend the polynomial interface. It has better numerical stability for fitting than polyfit does, which is, I think, one of the main reasons for recommending it. But there isn't feature parity. So there are some things that polyfit can do that polynomial.fit doesn't do. Yeah, so it really just depends.
And response from Mayush, thank you. Thank you for explaining. A question from Aaron. What's your approach in putting together a new tutorial requiring lots of writing and executing cycles? Do you stick with the writing the executable book and mist in the text editor, or play around with a Jupyter notebook first and then convert?
So I very much prefer working in text editors, but that's just my preference. I guess it's another thing that we can show is that, let me just reshare really quickly. So the other thing is that this text-based notebook format does support out of the box using the browser interface too. So if you really like working in Jupyter Notebooks instead, like working in the browser interface, that's totally fine. You can do this, and we just click which one we were looking at, tutorial MA. And so this, even though the source file is no longer this JSON blobs and is actually markdown, so that because of Jupytext, which is a dependency that we have installed that's working under the hood, it automatically converts between the two formats for you. So this all, the normal Jupyter notebook interface works just fine. And if you are more comfortable working in this way, then that's totally supported. You can do whatever you want. I personally like working in the text editor. The main reason is just I'm much more comfortable in a text editor, and also, like I sort of alluded to before, it avoids that problem. So one of the tricky things about Jupyter Notebooks, right, is that, like, okay, you're going down, you run a cell, and you get an exception in that cell, and then you realize, oh, I defined something wrong in a previous cell. So you go up maybe 3 cells, and then you execute that cell, and that changes the state, and then you go back down to the cell that had the exception, and you rerun that, and that cell works, but then there's 2 cells in between that may be depended on what the state from the previous cell was for something else. And so you can get into this very weird situation where your brain is thinking that everything is executed sequentially, but notebooks are flexible and don't necessarily have that guarantee, which I think is actually really dangerous for people who are learning coding through notebooks specifically, because that's like one of the fundamental tenets of program writing, is like sequential execution and flow control and things like this. But if you're aware of it, then it's not really a problem. So it's really dealer's choice, whatever you feel like doing. And Brigitte, you had your hand up. Did you have?
Yeah, you covered it. It's basically reasonably new that you can change the format So you can save the notebook into MIST format. You won't even see the NBPY files. So, yeah. So in many Jupytex, you need to install Jupytex before doing this.
Yeah. And that's another good point, is that the MIST NB text-based format is new, like relatively new anyways. It's by maybe 2020 was the first release or something like that. And the Jupyter ecosystem is massive. There's just like an incredible amount of tooling and all of this stuff around it. And so that means that not everything supports that the text-based notebook, for example. So like NBQA, it just off the top of my head, NBQA is a really popular like linting tool for notebooks. It only supports the the JSON.ipynb format. So if you want to use NBQA, you have to do a little manual conversion under the hood. You take your MD file, Jupytext it to an IPynB, run NBQA on it, and then Jupytext it back to MD. A little annoying, but the hope is that in the future, the MIST Markdown notebook format becomes more and more of a first-class citizen in the ecosystem, and things start to add native support for it. Given its utility, I'm hopeful that that will be the case, and I know that there's people in the Jupyter ecosystem who definitely want to see progress on that front, but it's a huge ecosystem, so it may take some time.
Yeah, and it's also like a feedback that I'm getting from many people, and I'm super excited about having this Markdown format and being able to edit it on GitHub, that they start panicking that it takes away the notebook that they edit in the browser, and no, just think about it. This is the 5 format, and it doesn't take away most of the things. And usually those people are not running NBQA anyway, so it just makes it easier to interact with notebooks and GitHub, or when you are coming in with a developer mindset.
Yeah. Oh, that's actually, let me just pop the screen sharing one last time, because I don't know if I actually showed the diff, which is what I really wanted to show. Oh yeah, I did. Right. So like compare this to if we were working with notebooks, this would be in some triply nested JSON bracket with an ID metadata that changes because the cell execution has changed, and probably some other changed metadata. But this is reviewable, right? This just looks like normal Python code that you would review. And let's also just briefly see if any of these checks are done. All right, cool. So that's the other thing that we wanted to show, is that as part of the CI system, you can see, so we build what the website will look like. So if you want to see your proposed changes rendered, you can go to master A, and we can see our, right? So we used this model. So this is our code. It renders this way, and you can compare it to, the actual hosted version here. So this is another really nice review tool that we, essentially stole from NumPy's main CI. This is how the documentation builds for NumPy as well. And so it's really nice. It's a really nice reviewing tool.
There is another question from Aaron. Sounds like he is inspired. So the question is, any recommendations for areas of NumPy that need some tutorial content?
All areas. So I think there's two main things. So like if we look at the categories that we have that NumPy features section, and then the NumPy applications. And I think both of them are valuable. So the purpose of like the NumPy applications is basically to see NumPy being applied to real problems. And that's nice, because if you're coming from image reconstruction, if there's an image reconstruction tutorial, then people who are interested in image reconstruction can see how NumPy is applied to that particular subdomain. And that might appeal a lot to people from that subdomain and really be helpful in terms of them learning best practices for how to apply the tools that NumPy has to that particular problem. Whereas the NumPy features is more like, okay, for example, the polynomial subpackage exists. Almost no one knows how to use it, including me. And I've worked on it a lot. So that would be something where just highlighting, what the interface is like and how you're supposed, the polynomial.fit, how you're supposed to use that, why you're supposed to use that instead of polyfit, which we talked about in words in this meeting, but there's no real concrete information in the documentation about why this is the case, which would be a nice fit for a tutorial. So